All right, so this is take two. My first one was corrupted after I finished it, so I've got a piece of paper here that I'll reveal what I wrote rather than writing it down again. So we're going to start a new topic, which is introduction to differential equations. This whole unit really is an introduction to differential equations. If you go on to do more maths at university, you'll find quite a lot of differential equations popping up. Now, to put simply, differential equation is just an equation that has a derivative in it. And it can have a whole lot of other things as well. Here's a couple of examples. So the first example is a really simple one. We've seen things like this before. The derivative of something in respect to x is cos x. Here's a more complicated one where we've got a mixture of different derivatives. So we've got the second derivative of something minus 4 lots of its derivative equals 0. So it's another equation with two different derivatives. We can even have the original equation feature. So the derivative of y is equal to itself plus x. So those are all just examples of differential equations. They occur often when we're looking at science. And why they occur is because the derivative is to do with the rate of something. So if you can somehow express the rate, then you can potentially go back to some information about the original thing itself. So you might have seen modeling a disease spread, and we know something about how it spreads or how the rate of change occurs. And then we can then use it to work out how many individuals you would expect to be infected at any one point. So that's a use of rate. But they occur all the way through physics, through chemistry, through biology, really common through all the sciences. And so they're a really important area of study. Now, as I said before, we might want to use them to find out something about the original. So we're going to look at this very first one, the simple one. And here we know that, well, if the derivative equals that, then we know the original equals the integral. So if we can find the equation that we can solve to get the integral, then we can solve it. And we know that that's going to be sine x, because the integral of cos is sine, and plus c. And we call that the general form. If we've got some extra information, for example, y at an x of 0 equals 2, we can find a particular solution. So you might know something about the general spread of a disease, and then if you've got the frequency of that disease at a particular time, then you can try to work out how it's going to go forward in time. So that would be the difference between the general and the particular. Now, hopefully this one won't corrupt. We'll see how we go.